All right, so we're going to be doing the 2000 free response question number 3. So you want to pause here and probably read the question. The figure above shows the graph of f prime. The derivative is given from the closed interval of -7 to 7. F prime has 3 horizontal tangents, -3, 2, and 5, and a vertical tangent at 3. So I'm actually going to take the graph and do some things with it, meaning I'm going to just highlight the horizontal tangent and the vertical tangent here at 3. So part A asks you to look at just from -7 to 7, and this is an open interval, meaning we're not going to use the endpoint. I do want to point out that the second that I saw this here, and I saw the graph of f prime, I actually could tell that f must have been continuous because there's no undefined on the derivative. It's differentiable for the same reason, no undefined on the derivative, and obviously it's closed. So if I needed to use the theorems, IVT, EVT, and MVT would all be valid from -7 to 7. So going back to part A, I want to find where we have relative minimum. Now I would look for a minimum by doing a sign chart. So hopefully that's all a nice line. This look neater. So I will be doing my sign chart from -7 until 7. I am doing the sign chart for f prime, and because I've given f prime's graph to make f prime's sign chart, I'm going to look at y values. So first thing I'm going to do is look at where the y values are 0. They would be here, here, and here. So I'm going to bring those down to my sign chart. -5, -1, +5. Those y values are 0. The y values before are positive. The y values in between are negative. They're positive, and now at the end they're positive again. Now I'm going to look for a minimum. So my minimum has happened when my sign chart changes from negative to positive. So this must be the minimum. How do I know that? X equal to -1, so this is my justifying. X equals -1 is min because f primed of -1 equals 0 and f prime changes negative to positive. All right? Look at part B. Find the values that you have a maximum. So I'm actually going to go back and steal our sign chart again so that I can answer that question. All right, so there's my sign chart again. And we have a maximum. So maximums occur when your sign changes from positive to negative. Now here, you'll notice it did not change. It went from positive to positive. So this is neither a max nor a min. So now I'm going to give my reasoning. X equal to -5 is a minimum, or sorry, a maximum, because f prime of -5 is equal to 0 and f prime changes positive to negative. All right, part C. Find the values for which the second derivative is less than 0. So we want the second derivative to be negative. And to do that, we're going to do another sign chart. And we're doing from -7 to 7 again. And we're going to do f double prime this time. And if I'm going from f prime to f double prime, that's one slope. And if I'm going one slope, I'm literally going to look at slope. So I got to look for where the slopes are 0. And remember, they gave us those values. Those values were -3, 2, and 5. The slopes are 0, 0, 0. You're going to look for where the slopes are undefined. Remember, your slope was undefined at 3. And now I'm going to look at the slopes, meaning does the graph increase or decrease? So the graph goes down, so that slope is negative. The graph goes up, the slope is positive. The graph comes down, the slope is negative. The graph still goes down, the slope is negative. Just to be clear where this negative is coming from is this piece right here. And then my very last sign is positive because my graph went up. All right, So I'm going to look for where the second derivative is negative, and there are actually a good amount of intervals. We're going to go -7 to -3, union with 2 to 3, union with 3 to 5, because f prime decreases. Letter D, at what value for x on the, now be very careful, now we're using a closed interval, and we want an absolute max. So let's go back and let's steal that first sign chart we did, which is here. Now I'm going to actually take this one, a copy of this from part B, because we labeled our maxes and mins. So, go to part D. See if I can paste it. There we go. Let's see. All right, so the difference now is we actually have to use the endpoint. So I'm going to look at this endpoint here. Let's look at the graph. The graph increases. So this had to have been a minimum because the graph went up after that endpoint, that's left endpoint. If we look at the right endpoint at 7, the graph went up, so it actually stopped at a maximum here. So we need to look at, when do we attain our absolute maximum? And what our two maximum values would be are x equal to 5 and x equal to, -5, and x equal to 7. This is a question where we would not be able to actually give the absolute. You're able to tell which ones are your maximum, and then we would have had to figure out from here the y values. But you guys don't know how to do that just yet. So we would have to leave it at, these are our two possible maximums, and once we figure out the y values, we would be able to say which one is the absolute. So in terms of reasoning, you would give the same reasoning for -5, but at 7, a lot of you have some trouble with your your endpoint. So at x equal to 7, that's a max because f prime is positive before. All right, that is question number 6.